Today in this video I will discuss the Bernoulli theorem. Bernoulli theorem. According to Bernoulli, the if a liquid is flowing in a tube of if an ideal liquid is flowing in a tube of varying cross-sectional area in streamline flow, then the total energy per unit volume is constant at every point of the tube. In the previous video, I have told you that there are three types of energy which a liquid have. First energy was pressure energy, second was kinetic energy per unit volume plus gravitational energy per unit volume rho gh equal to constant. This is the pressure energy per unit volume, this is your kinetic energy per unit volume, and this is your gravitational energy per unit volume. Now I want to prove it. Its proof. I consider this a liquid. This is a tube of varying cross-sectional area. This is the tube XY, and liquid is flowing in this tube in streamline flow. Let the cross-sectional area A1, speed is V1, and pressure is P1 at the end X. Similarly, here area of cross section is A2, velocity is V2, and pressure is P2 here. The liquid is flowing in this tube in streamline flow. Now, work done to enter the liquid through end X. That is, I have told you, work done, that is P1V, pressure into volume, V1 I can tell you, and to enter the liquid through the end X per second, you can also say per second. Now P1 A1 into V1. V1 volume. V1 is the volume of the liquid flowing or entering through the end X. And this is area into velocity. Work done by the liquid to and Y, that is equal to, in the same formula, P2 A2 into V2. Now net work done on the liquid per second, that is equal to, the work done by us is taken as work done P2 P1 A1 V1 minus P2 A2 V2. Work done by us is taken as positive and work done by the liquid is taken as negative. Now energy of the liquid at and x equal to the gravitational energy, the kinetic energy is half mv1 square plus potential energy mgh1, that the height is h1. Similarly, energy of the liquid at and y equal to half m v2 square plus mgs2. This is your kinetic energy, this is your potential energy. So what is the change in energy? Change in energy equal to half mv2 square plus mgs2. This was the energy at end y and this is the energy at end x. So the change is equal to m1 v1 square minus mgh1. By the conservation of energy, by the conservation of energy, work done equal to change in kinetic energy. Change in energy. Okay. Work done, I have told you that work done equal to, that was P1 A1 V1 minus P2 A2 V2 equal to change in energy. Change in energy, I have told you, half m v2 square plus mg s2 minus half m v1 square minus mg h1. This was the work done, net work done on the liquid, and this is the change in energy. By the conservation of energy, the work done should be equal to change in energy. Now, by the principle of continuity, by the equation of continuity, A1 V1 equal to A2 V2, I have told you, and this is volume of liquid flowing per second. So in place of A1 V1 and A2 V2, I can write V. Now write this P1V minus P2V equal to half mv2 square plus mgs2 minus half mv1 square minus mgh1. Now I divide it by v. Dividing the whole equation by v, you will get P1 minus P2 equal to half m by v, v2 square plus m by v, gs2 minus half m by v, v1 square minus m by v, gh1. What is m by v? M by v is the density, mass upon volume equal to rho, or that is density. So P1 minus P2 equal to half rho V2 square plus rho GH2 minus half rho V1 square minus half minus rho GH1. In place of m by v, I write rho. Now taking this in this side and in this side, P1 plus half rho V1 square plus rho GH1 equal to what is P2 plus half rho V2 square plus rho GH2. This is the total energy which the liquid possesses per unit of its volume. So when you get equation like this P1 V1 something equal to P2 V2, then that thing is constant. So I can write P plus rho GH plus half rho V square equal to constant. This is your proof of Bernoulli theorem. Okay.